Let's discuss how water is conserved by the kidneys. So water conservation. This is done largely by your collecting ducts, the ducts of collection. So let's first give you the physical situation in the kidney where you have your medulla. Remember, you have your medulla, and there's a pyramid in the medulla. So medullary pyramids. Up here, this part will be your cortex of it. So cortex up here, cortex of the kidney, and this is the medulla of the kidney. And you have these things called pyramids inside the medulla. So as you cross the medulla, the osmolarity changes. So it begins here in the cortex at 300. Once you enter the medulla, you get around 400 here, maybe 600 here, 800, 1,000, and at the very tip of it, it's about 1,200 milliosmolar. Okay, so the osmolarity here changes. That's called the osmotic gradient across the medulla of the kidney. And this is how it is. It's maintained that way, where it's less, the osmolarity is lower at the cortex, and as you go more towards the pyramids, towards the papilla of the pyramids, it gets successively bigger. Now, imagine here then that your CD, the collecting ducts pass through the medulla on their way down to your papilla to drip off the urine into the minor calyx. And so the filtrate that's coming in here, the filtrate coming in to your CD will come in at around 100. Okay, so that is your osmolarity of the filtrate entering the collecting duct, and as it goes through the duct, okay, the osmolarity out here will always be higher than the osmolarity of the filtrate going through here, and so it will lose water to the higher osmolarity as it passes through. So as it goes down towards the papilla, it gets higher, 400. Higher, 600. You can get as high as even 1,200. Okay, and the amount of water that gets pulled out, from low osmolarity to high osmolarity, depends on how many water channels are around. So the water coming out has to pass through these channels called aquaporin. So your aquaporin channels are water channels that can be inserted or removed from the ducts. Okay, so your aquaporin are water channels that determine how much water is pulled back. The more water channels that you have expressed, the more water is pulled back, and the more concentrated your urine will be once it leaves the pyramid to enter into your minor calyx and pelvis and into your urethra, to your bladder and urethra. So it's how all happens here in the CD. So now let's do a scenario here. So when there is no antidiuretic hormone, okay, in this case, the pyramid, like so, your collecting duct coming through will have no aquaporin channels. So with no ADH, there is no aquaporin channels, and therefore the filtrate comes in at 100 and will leave at 100 because it cannot escape out. So here, the urine that you make will be very dilute, very clear, watery, dilute urine, because there aren't any channels being exposed to the filtrate for water to leave. Okay, when you have, so this is one extreme, you're never that low, right? And then you have, the other extreme is when you have maximal amount of aquaporin around. So when you have high amounts of ADH, when you have high amounts of aquaporin, and then as the filtrate travels through the collecting duct, now you have a bunch of aquaporins in the tubes. These are your Aquaporin channels. And then as the filtrate comes through, comes in at 100, and it will pass at that. Water will just keep on being reabsorbed, or what's called water retention. Bring it back in, bring it back in. Okay. And eventually, you can bring back so much so much of the water can be reabsorbed that the filtrate will keep on getting bigger. So now it's at 200, 400, 800 even, as high as 1200 milliosmoles, because the water is being pulled back. This is what happens when you're on a very thirsty day. So let's look at how ADH is regulated, and then that will in turn explain to you how water is controlled. So this is how it works. So when the osmolarity of the blood goes up. So high osmolarity of the blood, meaning you're thirsty, you're dehydrated, will be detected by osmoreceptors in the hypothalamus, which will trigger the release of ADH. And then ADH will trigger the expression of aquaporin in the CD, and then water, you increase your water reabsorption in the collecting ducts. And the net effect is, by retaining the water, now the osmolarity of your blood will drop. This happens on a hot day. When you're thirsty, dehydrated, you make more ADH, which causes you to make more aquaporin, which causes you to retain your water, pull the water back out before it leaves the body in the urine. And the vice versa happens when you have low osmolarity. So in this case here, let's say you drink a gallon of water per minute, per day, per hour. Some people walk around big buckets of water to drink all day. That will lower your osmolarity, okay? And then that will eventually cause you to stop making ADH. So here, ADH does go down. When that goes down, that means this also goes down. Aquaporin goes down, which means water reabsorption also goes down. And then because you retain less water, meaning you'll lose more water over here, that means your blood osmolarity will go back up. And that's why if you drink a bunch of water, you're always in the restroom urinating, because your body doesn't want this to happen. It doesn't want you to drop your blood osmolarity. So you keep on getting rid of the urine. You pass it out because you make a bunch of it here. So here, this is high volume of urine in that case. This is low volume of urine when you are on a hot day. Okay. That's how you control your water in the urine, by how much ADH you make, which is in turn driven by how your blood osmolarity is, what is high or low. Okay.